Uninhabited areas are regions of the world that have little or no human presence. They can be found in remote locations such as deserts, mountains, islands, polar regions, or deep oceans. They matter because they are part of the natural heritage of the planet and they provide valuable services and resources for humanity and other living beings. So mapping uninhabited areas is very useful and it can help us witness the splendor and diversity of the world. By mapping the places that are untouched by human civilization, we can marvel at the wonders of nature and appreciate the variety of life forms that exist on Earth. Mapping also helps us monitor the health and changes of the world. By mapping the places that are affected by climate change, natural disasters, or human activities, we can observe the impacts and consequences of these events. Mapping uninhabited areas finally can also help us discover the opportunities and challenges of the world. The potential for exploration, development, or conservation can identify the benefits and risks of these activities and plan for the future needs and aspiration of humanity. So in today's tutorial, I will show you how you can easily map uninhabited areas for any country in the world. Hello folks, this is Milos. Welcome back to my channel as I take you on another exciting mapping journey with R. This time I'm going to show you how you can use global human settlement layer data to map uninhabited areas for any country in the world. So first of all, I'm going to show you where the data lies and how you can load it into R. Then I'm going to show you how you can crop the area specifically for Australia. And finally, we'll be using ggplot2 to create a very effective and beautiful map of uninhabited areas in Australia. Alright guys, today we'll be mapping uninhabited areas in Australia using the global human settlement layer. And let's first of all load the libraries that we need, and if we don't have them installed, to also install them. I like to start off by first of all defining a list of libraries that we will use in this session. So the first one is the umbrella package called tidyverse, which has packages for data wrangling and data visualization. For data wrangling, we're going to be using dplyr from tidyverse and ggplot2 for data visualization, so for mapping those uninhabited areas. The second package is the terra package, which we will use to load this GHSL raster and then also modify it. And then finally, we need to also load a national boundaries of Australia. And for that one, we can use gscor, which is the package to communicate with the gsco, which contains national boundaries for any country in the world. Once we have this, we need to determine if these are already installed on our system. So I'm going to create an object called install_libs, and then I'm going to search the row names of the already installed packages on my system. And then if they're not installed, I need to write a statement, which is an if-else statement, which says basically if any of these installed libs equals false, in other words, if it's not installed, then they should be installed. So install.packages is the way to do that. Now we don't need everything. We only need from the list of libs those that are not amongst the install libs object. All right, so this is going to install everything, and then the final step is to simply load all the libraries that we need. And for that purpose, we can simply apply to this libs list, we can apply the library arguments. And this is it. In today's tutorial, we'll be mapping uninhabited areas using the global human settlement layer, which is a dataset that shows the distribution of human population across the globe over time. It is calculated by disaggregating population estimates from census data or administrative units to grid cells using urban areas mapped as a proxy for population density. And as you can see on this map, this is the grids, and each of the cells is a raster file that contains population estimates for that part of the world. On the left-hand side, you can see that the data is available for the years, every 5 years from 1975 to 2030. And below that, you can see also resolution and the coordinate reference system. So for our purposes, we want to work with the WGS84 coordinate reference system, which is the default one. And then in terms of resolution, we have two options, either 3 arc seconds or 30 arc seconds. 3 arc seconds is quite crisp, so it's also file is also large. So we're gonna go for 30 arc seconds, which would correspond to 1 kilometer here. And then we're also going to choose 2025. Now, our option is to download each of these files for Australia and then put them together in R. But I suggest we go another route, which is downloading a single global file. So this for this entire area, and then cropping it in R, which is going to be much easier because this file already is going to be around 400 megabytes, and once we crop it, it's going to be even smaller. So I suggest we go ahead and copy this link that I just selected and go back into R, and using that link, download the data. All right, back in R, I'm just going to paste this link here. Then I'm going to wrap it up in quotes because R accepts string format. And then I'm going to say that this object is going to be called URL. All right, so once I do that, I also need one more thing, which is I need to define what is going to be the file name that I'm going to download. So we can get information on the exact file name from this last part. So this is the actual file name, this one here. So we just copy this and put into these quotes again. So as you can see, the file that we'll be downloading is in the zip format. Now we just use download file from base R. For the URL, we say that it's the URL which we define. For the path, we should be downloaded this to the working directory. So we also specify that. And then finally, for the destination file name, we just simply type here file name. Okay, so once we do that, we can start by executing all these lines, which is then download the file to our local drive. Our second step is to unzip the data and then load it into R in the form of the raster. So for unzipping, we're simply going to use unzip and then provide here the file name. And once we actually unzip, we need to load this raster file into R. So let's first of all define what is going to be the name of this raster file. The name is actually going to be the same name that zip folder had, but this time, instead of that zip extension, it's going to have TIFF extension for a raster. So we need to change actually that file name to a raster name, but getting rid of that zip and then adding the TIFF at the end. And for that, we can use gsub from base R. We just simply need to say here gsub and then say that the first argument is zip. This is what we want to remove. The second argument is TIFF. This is what we want to replace with. And the final part is the object to which we're going to apply this, which is going to be called file name. Once we do this, we can actually load the file as a raster file into R. So we can call it POP, which is like shorthand for population. And then we can use terra and a rust option and simply say here that we want to load raster name. So we loaded the global human settlement layer, but we only need the part for Australia. So the next thing we're going to do is we're going to get the national boundaries Australia, and then we're going to crop that global layer using the Australia national boundaries. In order to fetch the Australian national boundaries, what you can simply do here is you can create a function which is going to call gsco_r to do the job for us. So we can just simply say here that our object country is going to be based on gsco_r and its option gsco gets countries. Within this one, we can specify two things, but one of them is the most important, which is country. Here you should provide the ISO2 code for the country that you want to plot. In our case, the ISO2 code for Australia is AU, and we can also provide the level of detail for Australia, which is called a resolution. Resolution of 1 is the crispest possible resolution. The next one is 3, so we're just going to go for 3. And then finally, we can simply return this object, and then outside of this function, we can call it, and this will create the simple features object of Australia. All right, our next step is to carve out the GHSL for Australia, and we're going to first of all create an object which is going to be called Australia pop, and here we call to rescue terra and its function crop. So in order to crop, we first provide the name of the raster layer that we want to crop, and second we provide the name of the shapefile that we want to use for that. Now this pop object is already in the terra format, but country is in a simple features, and terra works best when both objects are in a terra friendly format. So for that reason, we will simply coerce this country object into a vector format, which is a terra friendly format. After that, we also need to tell Terra that we want to only include those things that are inside of the borders. And finally, we also want to tell Terra here to exclude everything that is outside of the Australian national boundaries. In order to plot this raster object in ggplot2, we first of all need to convert this raster object into a data frame. In other words, we need to get the average value for each of the raster cells of that raster object, and then present them as coordinates in a data frame. So this is how we're going to do this. We're going to create a new object called australia.df, and then we are going to use this option which is called as data frame. So we're going to coerce Australia pop into a data frame. And here we want to have coordinates of those cell centroids along with, of course, the values for each centroid, which is going to be the population count. And of course, we're going to also say here that we want to remove any NA values. And this is the data frame that we got. So it has X and Y fields. So these are longitude and latitude coordinates for each of the centroids of the cells. And the third one is the value, which shows actually the population for that specific centroid of raster cell. But as you can see, it inherits the name of the raster object itself. And we don't want that. So we're going to actually next rename this third column into something more appropriate, which is going to show, the values. Okay, let's change that name. So we're gonna do this by, first of all, accessing the names of the data frame. And then we're going to say here that the third column is going to have a different name. We're just going to rename it to val, which is a shorthand just for val. And then the next thing what we want to do is we want to actually, instead of having, the number of people that live in each cell, we just want to see if someone lives or not. So basically those values that are higher than 0, this is where people live. And that's going to be termed as 1 or a yes category, whether they live, and the one which is simply equal to 0, this is one going to be where people don't live, right? So we are just simply going to modify this data frame by creating a new column, which is simply going to be the category of whether people live or not. Simple as that. And for that, we can use the dplyr package and the mutate function, which allows you to create a new fields. Now here we can conveniently use another function from dplyr, which is called if-else. In other words, here we can say if our value is higher than 0, then I would like this new column cat to be yes, right? Yes. And if it's actually not the case, so else, it's going to be no, because else is, since population cannot be negative, then it's going to be equal to 0. So then no. All right, so this is how you do it. And after that, this newly created object is going to be a character, a string, but we want it to be a factor. So we can simply declare it as a factor like this. So we just say here as factor, and then simply copy and paste it here again. And we are finally ready to map. First of all, we're going to define colors. So I chose this navy blue color for the absence of population, and I chose this yellow color for the presence of population, but of course you can choose your own values as well. First of all, we're gonna create an object P, and then we're gonna call ggplot. After we are done with that, we can add our first and only layer, which is going to be based on geom raster, because it is essentially a raster which was turned into a data frame. So here we simply define our data. Data is called Australia pop df. And our main aesthetics is going to be to fill these raster tiles with a certain color based on their values. So for that purpose, we can simply use here this cut variable that's created. But there are two other things that are necessary, which is x. Well, x equals x because I didn't change that one, and y also equals y. So here we are gonna be plotting those points and filling the points with the appropriate value. That's it. Everything else that comes after this is simply customization. So one of the things that we can customize is definitely the colors. So we can assign here the colors that we want to give. So scale, fill, manual is the way to do that. Because we are working with categorical values, there are only two values. One thing we can do here, we can create a legend title. And I want to be witty here, and I'm going to say that my legend is going to be written like this. Are there any people? Question mark. So then we will have two answers, yes or no. All right. And then for the colors, which is here defined by values, I'm just going to assign those calls. And then what happens if I actually have missing values? Well, I can also, deal with this. I can simply say here NA value, and then I can assign to the NA value the absence of population. That way we actually manage to have absence of population and the missing value to be the same color. So basically uninhabited areas. All right, once we are done with that, we can go ahead and also customize the legend a bit. And for that, we can use guides argument. Our main aesthetic is a fill aesthetic, so we define here. And then we say here that this is a guide legend. So in other words, a categorical legend. I would like my legend, first of all, to be horizontal. And this is what I'm actually doing now here. I'm saying for direction equals horizontal. Then I can also define here, for example, key height. Key heights and key width. These are in units, and I'm gonna go for the height, which is 5 millimeters, and then for the key width, so I would like it to be a bit longer. Let's say 15. 15 should be 5 millimeters. And then my labels, I would like them to be below the legend. So I'm just gonna here put that the label position equals bottom. Title position is going to be at the top, so I don't think I'm gonna change that. What I can also do is I can horizontally justify the labels. I can put them into the middle, and I can also say here that the number of rows is going to be just 1, and I would like to organize those legend keys to be next to each other. I also like for the theme to get rid of any access things in the background, so I'm using for that purpose this theme void. But then because I do want to customize certain things, I open up again this theme, and then I can do this. One thing that I want to do is, for example, I would like to specify the legend position, and I can, for example, take top here as the legend position. So this is going to place it on the at the top where title could be. Then I can also specify, for example, legend text, or let's say legend title first of all. And because this one is a text, I need to tell ggplot that it is a text. That's why I'm writing here element text. And here I can define the size in pixels. Let's go ahead and have a bit bigger legend title. So let's say pixel size 14, but for the color, I'm just gonna go for charcoal gray. And then I can also define other things, such as, for example, legend text, which is gonna come just below those bars. And let's say, for example, let's say I go for legend title, which is 16, and legend text 14. I really want this to stand out so people see right away what the map means. And then we can also, for example, use the caption to present the source of the data, which is always a smart thing to do. Captions, like legend text, they're text. So we tell ggplot to, again, this is text. In terms of the size, caption can be smaller, let's say 10, but I can still go for, let's say, gray 10, which is charcoal gray color. And then I might push it a bit to the left-hand side. So if you go closer to 0, and I chose here 0.25, you're moving to the left-hand side, so it's going to be left justified. And finally, I want to push it towards the map, so that's why my vertical justification, or VJust here, is 20. Of course, all these things you can play with them, they're not set in stone, and you should definitely try and change them and see how the map looks like. Finally, I want to play a bit with the margins. And plot margin here is going to help me to basically increase the focus on Australia and just kind of shrink everything around it. And the way to do that, you need to specify here a list of 4 arguments. How much you want to shrink the top side? Well, for the top side, I don't want to shrink it that much. I'm just going to keep it at 0 because I do have that legend. I don't want that legend to disappear from the plots. But the bottom side, which is denoted by B here, I'm going to shrink it a bit. Left-hand side denoted by L as well, and finally the right-hand side denoted by R. Also, I'm going to shrink it a bit. Here, very importantly, you need to also define what is going to be the unit measurement, and I put here lines, but you can also go for inches or centimeters. And then once we are done with the theme, we can also define for example, some things like, for example, caption. All right. So in this tutorial, we don't need a title. So if you don't need something, you can simply leave it like this. This is going to tell ggplot2 not to print anything for this specific argument. But for the caption, I would like to have something. So I just want to put here that data is the global human settlement layer. And I can say here at 30 arcsec. Yeah. All right. So again, this is the data for 2025. These are the global estimates for that. All right, ladies and gentlemen, this is the final map of uninhabited and also inhabited places in Australia. And you can clearly see that the east of the country and also southwest are mostly inhabited. And there is a huge gap in the middle. So a lot of the space is actually empty. All right, that's all for today, ladies and gentlemen. In today's tutorial, you learned how to create a map of uninhabited areas for any country in the world. We created a map of uninhabited areas for Australia in specific, but I'm really looking forward to your own use cases and how you can take this tutorial on a journey across the world. If, however, you would like to replicate today's analysis, I've prepared a repo with the code in the description below. If you have any comments, questions, or just general feedback, feel free to reach out to me here on YouTube, but also on Instagram and X. Also, if you're new to R and you seek to expand your data visualization and geospatial knowledge in R, I've prepared a few very useful tutorials, so check them out. See you next time.